The first question, I guess, is what are molecular properties? Well, actually it was a few years ago, well, several years ago, asked to write a chapter in some textbook which had the title, Other Molecular Properties Than the Energy, which sort of is the definition of molecular properties. That is everything else than calculating the ground state energy of a molecule, or also excited state energies in a way. So it is all kind of expectation values of other operators than the Hamiltonian, or other observables, something you can measure, which can be calculated from the wave function. And so it's not the energy, it's not the density. I mean, the density is the sort of the square of the wave function, but it's not the density and the energy, it's anything else. And I like to distinguish between two kinds of properties. Properties which we know from classical physics. An example for that is the dipole moment. And some of you had some kind of an electromagnetism course, and you might have heard about the dipole moment in that context. And there are quadrupole moments and other moments. So that's a kind of property which we know from classical physics, and then what we have to think about or find out is what is the analog in quantum mechanics? Well, how can we calculate that from quantum mechanics? And then there are other properties which are related to spectroscopy. And then in this way have no real analog in classical mechanics. And the one which I personally first of all think of is NMR spectroscopy, where you have things like the chemical shift, or the spin-spin coupling constants, coupling constant, etc. You could also think of ESR, which is sort of the analog to that for the electron spin, where you also have coupling constants and where you have something which is very much analog to a chemical shift. And then of course we have just UV with excitation energies, and oscillator strength or transition moments. Now, as I said, those two, on Thursday, you're going to play with those properties. And then in a few weeks, we're going to look at those.